rational, irrational. Yep. You start looking at letters that represent numbers, so algebra. So numbers have changed a lot since preschool, haven't they? So all of those kind of groups of numbers that you mentioned at the start, these are called sets. So this is called set notation. So groups put into symbols. So write this down. Set notation symbols. So integers is represented by a J or a Z. Don't ask me why, I don't remember. Does anyone know what an integer is? Whole, positive or negative numbers. Sometimes you'll see a Z plus. So what do you think that means? Positive integers. Or you'll see a Z minus, negative integers. The next group or set is called rational numbers, and that's Q. So does anyone remember what a rational number is? The definition is you can put it into a ratio. So you can divide a number by, or an integer by another integer. That makes it rational. So 2 over 3 or 0.666 reoccurring, they're rational numbers. The last one we're going to focus on, there are others, is real numbers. So pretty easy to remember, capital R. What's a real number? Is it one you can see in the wilderness? It's real. So real numbers is basically all of these numbers that we've described. It's the mega set. So all of these numbers are real. 0 is real, -1 is real, half is real. So we have all of these symbols, element of, union with, write all these down, intersection with, all the set except. So writing a set, we use these squiggly brackets. So here's an example. The integers between 3 and 7, the set is squiggly bracket 4, 5, 6. So if x is an element of integers and x lies between -1 and 3, it's also equal to 3, then the set of possible values for x, again we're using the squiggly brackets to represent the set. The squiggly brackets is like a Woolies bag and you're chucking all the numbers in the set. So 0's in the bag, 1's in the bag, 2's in the bag, and 3 is also in the bag. So the set of all real numbers is a continuous set and is given the symbol R. We can describe sets of real numbers with statements. So that's an example. We can also use these brackets to represent the interval. So we can describe them with statements or interval notation or number lines. So there's 3 ways to describe sets. It's the main thing I want you to write down right now. The new one to you this year is probably the interval notation. So the square brackets means the numbers included. So I'll do this one up here as an interval notation. So is the -1 included in this example? Is it included? No. So this one, we would use a round bracket for the -1. Not included. And what number does it go up to? 3. And is 3 included? So we use what bracket? The square. Because there'll be questions like, solve this equation under this interval, and then it'll use these symbols. So that's why I'm starting off with this topic, so you know the symbols. So what did I say 2 was an element of? That's what that symbol means. It's an integer. It's also real. So you can write either. So is it whole? No. Is it rational? So we can express it as a fraction. So this, we could write Q, or we can write real R. The next one, pi is an element of. Is it a whole number? It's not a whole, it's not rational, so it's just a real number. So square root 2 is equal to 1.41, doesn't stop, it keeps going. So it's a real number. You're kind of getting the language. All right, we're going to draw a number line now. This one is all real. So it's every single number. X is an element of all real. So if it says integers, you just do dots. So it's not including -3. So it's this one, this one, this one, this one, this one, and this one. So these are all the numbers in this set. So X is an element of real, but it's also the set is less than -4. So it's open because it's not included. It's less than, so it's going left. So we've been drawing graphs from numbers. Now we're being given graphs and we're going to figure out the numbers. So we have to use the brackets. So X goes down to -infinity. And it starts at 2. Next one is -3 included. Is 5 included? So it's a round bracket. So that's the interval notation for those two. So what brackets are we using for 1 and 3? 1, 3, 3's not included. And we're unioning it. Don't think that's a word. It's unionized. Square bracket for 5, because 5 is a closed circle, it's included. And what am I going up to? Infinity. We use round brackets for infinity.